So, good evening. I would like to welcome you to this manufacturing processes and casting and joining course, which is being taught by Professor Sonak Kumar Chaudhary from IIT Kanpur. So, my name is Rakesh. I'm a doctoral student at IIT Bombay. I'll be the TA for this course. So, every week from Saturday 6 to 7, I will be taking this course, and I will be interacting with you guys. I will also solve some numericals as well as discuss some innovative concepts or any theoretical concepts that are not clarified while teaching. So this is like a week 0 course. So there are some already questions floated in the course. So I'll be just going through all these things. So this is a 0 week course assignment. So there will be no marks for this. So that's the why I'm solving it. But later on, these assignments will be graded. So I will not be discussing them. But you can always discuss with me through the discussion forum. So going to the concepts. Uh, so from the title, you might have seen. So it's all about casting, foundry technology, and the welding part, which are the like basics segments of these manufacturing processes, apart from the forging and all other things. So there are some basic questions that will trigger you or improve your thought process to go further into these concepts and get interested in it. So there are some questions I will be solving, and I will also be interacting with this. So the first question is like a pattern in sand mold casting is used to. So there are four options in which uh, one is obviously you are guessing. So that is like from the mold cavity, and there is one more question. So all of the options are very closely related to this pattern. So one is get proper shape and final product, which is true. The second one is form the mold cavity, which is true, and the third one is get good finishing of the casting. To some extent it is also true, and the final is compensate for the contraction during solidification. So all the four options are very closely related, but if you think in fundamental way, the second option is like the most appropriate answer for this. It is just to form some mold cavity inside the that is the primary goal. Then the getting good finish, getting proper shape, the final will be the addition to it. And if you see the fourth option, compensate for the contraction during solidification. So it will be compensate for contraction during solidification, but only for the liquid uh, contractions, not for the solid contractions. So it is not completely specified, so we can ignore the fourth option here. So the correct option will be the second one. So that being said, the second question is like basic factor to be considered during the design of sprue in casting is. So you might have remember the sprue to which this pouring basin will be attached, in which the ladle will pour the molten metal into it. So this sprue will distribute to the from the gates, it will distribute to the mold cavities. So most important of this sprue is that, so we don't have any dimensions, but uh, so its shape is like the most important thing. So the most economical shape is like the conical one, but which is not easy to easy to produce in castings. So mostly we opt for the cylindrical type shape of the sprue. So that being said, so the next question is like basic factor to be considered during design of riser in casting. So if you think riser is for mostly to give the material so during liquid contraction. Okay, so it should be the last thing to solidify. So it should have very high volume to low surface area ratio. So that's the third option. It should have very high volume to area ratio. So the volume should be more so that the heat content in that will be more. So it can remain in molten form or heat content molten form to compensate the liquid during solidification. Next question is cores are used in sand mold casting process too. So this is obviously cores we use to produce a hollow cavity if we need in a casting. So that's the option A. So next question is like final parts in casting can be produced in net shape, not requiring any further processing in. So if you remember, if you are aware of these castings, so the first option is itself investment casting, also known as precision casting. So in which we'll directly get the net shape product. When sorry for that, I am discussing fifth question. So investment casting, also known as the precision casting, in which we directly get the net shape product when compared with the sand centrifugal castings. So next question is like which one of the following statement is correct? So these are the type of questions that will consume more time. So first option is like a casting with lower volume to surface area ratio cools and solidifies more slowly than one with the lower ratio. So if the surface area is more, lower volume and surface. So if I can interpret the question in option like if the surface area is more, then it should cool fast. So the option A is wrong. Second option is like a casting with higher volume to surface area ratio cools and solidify more slowly than with the low ratio. So this option is correct because the volume is higher when compared to surface area ratio, which is true. We discussed earlier in the concept of riser. So there we can stop itself. Let us see the third option. Cooling and solidification of casting do not depend on the volume surface area. It's false because it will depend upon the in given circumstances it will depend. So casting with a higher volume to surface area ratio cools and solidify faster, which is opposite to the option B, which is wrong. So next question is like select the right statement. Welding can all be performed on metals that have the same melting point. No, it's not true. We can perform even if the melting points are here and there. The second option is welding can be accomplished between certain combinations of dissimilar metals. Yeah, this is true. The heat affected zone is a region of base metal surrounding the fusion zone in which the melting has occurred. So in heat affected zone the melting will not happen. So this option is wrong. The unit melting energy is the amount of heat energy required to melt 1 cubic centimeter of metal. So it cannot, of course this is true, but it should not be in centimeter. It can be meters. It can be it should be a unit value, not specified in certain units. So the appropriate option will be B. So next question is for metallurgical reasons it is desirable to melt the weld metal with. So this is very direct question. Like so if you see high power, low power, high power density, low power density. So if the power density is low, so we can see that uh, we are giving very less heat to the welding zone. So what happens is the cooling will be slower. So it also depends on the metals. So I will give some small examples. So for example, high power density, I can say laser welding. So in which we are having very high concentrated energy but within small area. So in such a way that we are avoiding the heat affected zone and we are performing very neat and clean joining of the weld two metals, plates or something else. It is not always true because the gap should be within certain range to perform these things. If the gap is too long, too broad, we cannot perform every time. We cannot perform these things. Uh, so this is like the end of the question type answers. So ninth question, failure in welding often happens in the heat effect zone due to. So the option is like metallurgical damage occurring in this region, insufficient melting, overheating, slow cooling rate at this region. So if I come from bottom, slow cooling rate in this region. So this completely depends upon the material. So if the thermal diffusivity of the metal that is being welded is higher or lower, it dictates the cooling rate. So overheating and insufficient melting, these are like the operation parameters which cannot be true always. So the first option, which is metallurgical damage occurring in this region, is true because in heat affected zone this happens every time. So the cooling rate may be higher, may be lower, but there is certain change in the metallurgical properties, the grain structure, which finally results in the change in its mechanical properties at that area. So the first option is being the right one. So the final question is like filler metal is not utilized in. This is so contradicting question because the option C is like that. So arc welding, so definitely we will use filler metal. Resistance welding, I will keep for that for some time. So the next one is gas welding, we use filler metals there also. Then diffusion welding, so in diffusion welding we'll directly keep uh, two metals that we are going to join, and we will apply some pressure, and we will heat to near to melting point, so that the bonding will happen. So we will not use any filler. So similar way in resistance welding also, we will keep two plates, and we will apply some resistance, ultrasonic or whatever, or we will take two shafts, and we will keep one shaft constant, other shaft we will rotate with some torque, and we will stop. So we are not using any filler materials. So in this question, both the options will be true, but the